Hi, Assalamualaikum. I am Nurin Izzati binti Ismail, matric number 181811. And my name is Ailu Syafiqah binti Ismail. My matric number is 182605. So today we will present about pipeline. So for the introduction, the pipeline is a technique used in design of computers to increases the instruction, and it also increases the instruction by performing multiple operations in parallel. Next, it does not reduce the time to complete an instruction, and also operation that decompose into a sequence of sub-operations with same complexity. So the figure shows the slow way of pipelining. So from the figure, it shows that the sequential laundry takes 6 hours for 4 loads. If this
So for the pipeline laundry, it takes 3.5 hours for 4 loads, and it is a multiple task operating simultaneously using different resources. And it doesn't help latency of single load, but it helps throughput of entire workload. Next, for the pipeline rate, limited by slowest pipeline stage, and the potential speed up is equal to number of pipe stages. Then the unbalanced length of pipe stages reduces the speed up, and then the time to fill pipeline and time to drain, it also reduces the speed up. Now I want to talk about how pipelines works. The pipeline is divided into segments, and each segment can execute its operation concurrently with the other segments. Once a segment completes an operation, it passes the result to the next segment in the pipeline and fetches the operations from the preceding segment.
Next, the figure shows the pipeline instruction. It consists of 5 stages of instruction, which are IF, ID, EX, M, and WB. The instruction fetch (IF) is responsible for obtaining the requested instruction from the memory. The instruction decode is responsible for decoding the instruction and sending out the various control lines to other parts of the processor. The execution is where any calculations are performed. For the memory, it is responsible for storing and loading values to and from memory. The write back stage is responsible for writing the result of a calculation, memory access, or input into the register file. There are several advantages. The first advantage is more efficient use of processor. Next, it is quicker time of execution of large number of instructions. The disadvantages of pipelining are it involves adding hardware to the chip, and it also is inability to continuously run the pipeline at full speed. There are two types of pipelining. The first one is software pipelining, and the second one is hardware pipelining. Next, for the software pipelining can handle complex instructions, and it also allows programs to be used. Next, it is hardware pipeline. A hardware pipelining offers higher performance and also help designer manage complexity. Inside the pipeline hazard, it consists of data hazards, control hazards, and the last one is structural hazards. Based on the figure given, it shows that the construction of the data hazard. The data hazard is an instruction uses the result of the previous instruction. and it occurs when instruction tries to read register in ID stage. The next one is about the control hazards. The control hazards is the location of an instruction depends on previous instruction, and the solution is store the pipeline based on the figure above. Based on the figure above, it shows the construction of the structural hazards. The structural hazards is a two instructions need to access the same resources, and it also simultaneously support all instructions in the pipeline at the same clock and cycle. The pipelining also has stalling, which can be referred at the figure above. Stalling, it involves halting the flow of instruction until required result ready to be used, and wasted processor time by doing nothing while waiting for the results.
Today I'll be teaching you what is pipelining in Superscalar. Come here, my employees. Only perform one instruction at a time. After the instruction is completed, now the next instruction can be performed. Pipelining divides an instruction into steps, and since each step is executed in a different part of the processor, multiple instructions can be in different phases each clock. I'll be teaching you hazards now. Now let me explain what is hazard.
Firstly, structural hazard. Structural hazards occur when a hardware resource has been requested by more than one instruction at a time. We'll first see what happens when structural hazard does not occur. When there is enough hardware resources, as shown by the pin brushes the workers are holding. With enough resources, it is enough to support parallelism and there is no stalling, so it functions as a pipeline should. However, when there is a lack of resources, it is not enough to support parallel execution of instructions, and no new instructions can be fetched. Stalling will occur. This is seen with a reduce in performance. To prevent structural hazards from occurring, there should always be enough hardware resources.
The instruction will get all its existing data from the memory. Then the instruction will add in value. Before the next instruction can fetch the existing data, it has to wait for the current instruction to write to memory. After it has written back to memory, it can now fetch data from the memory. This continues, so on and so forth. The first instruction reads the data from the memory. Before the first instruction writes back to the memory, the next instruction reads the existing data in the memory. Then the first instruction writes back to the memory with value. When the next instruction tries to write back, there will be an overlap error. Control hazard is when fetch cannot continue, because it does not know the outcome of an earlier branch.
But it's no use, 'cause you
When branching is executed, current instructions will be dropped. I have a top priority instruction for you. Get it done now. Alright workers, we have a top priority instruction. Let's start now. After branching is completed, it will continue its original instruction.
In conclusion, pipelining promises fast CPU by starting execution of one instruction before completing the previous one.
And there are 5 stages pipeline for RISC, which are IF, IB, EX, MEM, and WB.
That is all from